Hi folks, this is Professor Watts coming at you with a short tutorial that shows you how to calculate elasticities of demand and supply. First off, we'll do a brief review of definitions, the basic concept of elasticity. And if you feel that you're comfortable with the definitions, you can feel free to skip right ahead to the sample problems towards the end of the video. Now, elasticity simply refers to the responsiveness to change. And when we're talking about demand elasticity, or technically speaking, the price elasticity of demand, we're talking about how responsive is quantity demanded to a given change in price. We know because the demand curve slopes down that when price goes up, quantity goes down, but we want to know how much. And elasticities of demand can be labeled elastic or strongly responsive. That means the quantity changes proportionately more than the price. So if the price goes up by, let's say, 50%, quantity might go down by something like 90%. That would be elastic, strongly responsive. Unit elastic, where price and quantity changes are equally responsive. They change by the same proportion. So if price goes up 20%, quantity goes down by 20%. And then inelastic, quantity is weakly responsive to changes in price. Quantity changes proportionally less than the change in price. So if the price doubles, increased by 100%, quantity might only go down by something like 5 or 10%. Okay, and when we get into the problems, we'll talk about different kinds of goods that have different elasticities. We're talking about elasticity, which is responsiveness to change, or you can think about it in terms of the responsiveness to a force that's acting on an object. In the case of demand for a product, the force is the price change. But let's take something that is elastic that we know about, a rubber band, and the force acting on it will be my hands pulling it apart. So I apply a given force, and the rubber band easily moves. This is highly elastic. I'm applying a very light force with my hands, probably maybe a pound worth of pull, and this thing stretches quite a bit. So that's elastic. It moves a lot in response to a given force. Now something that's not elastic, my ruler. I'm applying the same force. In fact, I'm pulling probably even a little harder, but I apply the same force and this thing doesn't move at all. This is very inelastic. So it's not responsive to being acted on by a force. So here's something that's inelastic, doesn't really move or change in response to that force. Here's something that's elastic, moves a lot in response to the force. So what's something in between? I'm going to find something that moves just a little bit, but my tie, the fabric will move. If I pull on my tie, same force, it moves a little bit. So this is slightly elastic, but it will have a low elasticity coefficient. The rubber band would have a high elasticity coefficient, and my ruler would have a very low to zero elasticity coefficient. Okay, so we hopefully have a good intuitive understanding of what this concept of elasticity means. And let me note before we move on that demand and supply elasticity are completely analogous concepts. So if I jump to the definitions of supply elasticity, everything's the same. And notice I've just replaced the word demand with supply here. Price elasticity of supply is how responsive quantity supplied is to a given change in price. And then we can say whether it's elastic or inelastic. Okay, one more quick definitional item. The concept of measuring elasticity with elasticity coefficients, which we'll start doing in some sample problems in a moment. That's indicated with the Greek epsilon, and it can be either greater than 1, which we'll label as elastic officially. It's equal to 1, that's unit elastic, or it's less than 1, being inelastic. Let's talk about the formula for elasticity, and we'll notice here that there's a problem that could skew the results, so we'll need to make a refinement of our formula before we can actually apply it to some problems. The basic formula is really simple. It's just a percentage change in quantity demanded divided by the percentage change in price. So we're looking at a typical demand curve. Price goes up, quantity goes down. Price elasticity, therefore, is always negative. Price is going up, quantity is going down, that means the numerator is negative. Or if price is going down, quantity is going up, that means the denominator is negative. So price elasticity is always negative. And we typically will talk about the elasticity coefficient just in absolute value terms. So we know it's negative, so we just want to look at the magnitude of it. Okay, and here's an example using that really simple formula. Price of oil increases by 10%, the quantity demanded falls by 5%, then the price elasticity is, well, that minus 5%, that's the percentage change in Q, divided by the plus 10% change in P, minus 0.5, or just 0.5, as I mentioned, we'll use absolute value. Okay, now there's a problem. Let's say you run a website design company, and you know that at a price of $250, you could sell 8 units per month. At a price of $200, you could produce 12 websites per month. Now, how do we calculate elasticity here? Well, as we'll notice, it's going to depend on whether price is going up or down, and therefore quantity going up or down. Now, the problem is the percent change is going to be different depending on where we start. If we start at A and the price goes up, we'll get one set of percentages, but if we start at B and have the price go down and the quantity up, we'll get a different set of percentages. Specifically, if the price is rising from 200 to 250, that would be a change of 50 divided by the base of 200, so that's a plus 25% increase in price. Quantities going from 12 to 8, that's a change of 4 divided by the base of 12, so that's minus 33. So our elasticity in that case is 1.3, which we would label as elastic because the elasticity coefficient is greater than 1. However, if we start at B and go to A, price is going down, we see the price change is 50 over 250, which is just 20% now, and the quantity change is plus 4 divided by 8, which is now 50%. So now our elasticity coefficient is much higher, 2.5. It's almost twice as large, in fact. So we're going to get a skewed result depending on where we start here. So we want a better method that kind of evens out that effect. So what we're going to do is use what's called the midpoint method. And to calculate these percent changes now, we're going to take the difference in price or the difference in quantity, and instead of dividing it by one or the other endpoint, we're going to divide it by the midpoint or the average value. It doesn't matter what end value and start value we use because we're only taking the difference. So we'll get the same result either way. So whether the price is going up, quantity down, or the price down, quantity up, we'll get the same elasticity result. So we're going to focus on this midpoint method when we calculate elasticities. And for our little example problem here, our percent change in quantity now is the difference, 12 minus 8, or 8 minus 12, if you will, which is 4, divided by the average, 8 plus 12 divided by 2, which is 10. Or you can just visually think about the midpoint here, right between 8 and 12, halfway between 8 and 12 would be 10. Okay? So our midpoint percent change in quantity, the difference, 12 minus 8 divided by the midpoint, which is 4 divided by 10, 40%. Okay, now our percent change in P, likewise, the difference, which is 50, whether we're going up or down, it's $50 change. And the midpoint between 200 and 250 is 225, or if you prefer the average, 200 plus 250, 550 divided by 2 is 225. Okay, so now we've got our midpoint percent change in price, and that's going to work out to 22.2%. Now we calculate our elasticity of demand. Our percent change in quantity, 40, divided by our percent change in price, 22.2. We got a nice midpoint elasticity value of 1.8. Okay, so just to summarize the formulas, our basic elasticity of demand is simply the percent change in quantity divided by the percent change in price. Our midpoint elasticity is the change in quantity divided by the average quantity divided by the change in price divided by the average price. Likewise with supply, same exact calculations except on the supply curve. So when we're calculating elasticity of supply, we're just looking at the percent change in quantity supplied divided by the average quantity supplied, the percent change in price divided by the average price. Okay, let's work some example problems now. Okay, so we're starting off with navel oranges, and you'll notice first off that my price is always in dollars per unit, and the unit here would be pounds. My quantity is always in units per time period, pounds per week. And I did make up these numbers, but they'll be somewhat close to the prices we would actually observe in real markets. So I'm going to start us at $1 per pound. And at $1 per pound, we're going to say that this market buys 10,000 pounds per week. Just label that 10K. Then we'll have the price fall to 85 cents per pound. And at that price, the sales go up to 16,000 pounds. Okay, now when we have a segment of our demand curve here, we could kind of draw a demand curve in here. We don't need to, but that's fine. Now let's bring in our equation, percent delta Q over percent delta P, and remember, using the midpoint formula, it's delta Q over average Q divided by delta P over average P. So it's simply a matter of plug and chug now. Our delta Q is 6. Our average Q is just the midpoint between 10 and 16, or 10 plus 16 divided by 2. It's going to be 13. And I don't need to write the zeros in there. I could if I needed to, but either way, the division problem will be the same. My delta P is 15 cents. And my average P is going to be the midpoint between those, or the average, 0.925. Simply perform the calculations. So the numerator is 6 divided by 13, 0.46. We can round this. And the denominator is 0.15 divided by 0.925, 0.16. Do that, and we work out to elasticity coefficient of 2.875. Let's call that 2.88. And of course, that registers on our elasticity spectrum as highly elastic. And as we might expect with oranges, you've got a lot of good substitutes, other fruits and other food products. So you're not necessarily going to you're not going to get excited about buying oranges until there's a significant decrease in the price. Okay, now another demand elasticity problem. Let's look at the demand for household electricity. And this time we'll make the price go up. It starts at 6.8 cents per kilowatt hour. And at that price, we have 300 kilowatt hours per month demanded. This is maybe for an individual household. The price rises to 8 cents per kilowatt hour, and demand only falls slightly to 290 kilowatt hours per month. And once again, we could kind of sketch in our demand curve there, but what we're interested in is elasticity. So once again, we just want to plug and chug into the formula. The delta Q is a change of 10 kilowatt hours. The average Q would be the midpoint, 295. The delta P is 1.2 cents, and the average Q here, simply 8 plus 6.8 divided by 2. 8 plus 6.8, that's 14.8 over 2, 7.4. Okay, then we work out all this math. We get 0.034 divided by 0.16, and that works out to, I'm rounding, 0.21. Elasticity coefficient of 0.21, well less than 1, so we would label this as inelastic, and this would be quite inelastic. It might make sense when you think about home electricity. There's not many good substitutes, and people are going to be willing to pay higher prices to keep their homes lighted and heated and not necessarily cut back that much on electricity use in the short run, even when the price goes up. By the way, I want you to notice that my percent change in price, 16% here, and back in my oranges example, 16%. So I did exert the same force, if you will, the same price change. And here we see a rather large quantity change, 46%, for a large elasticity coefficient. And here with the electricity with the same price change, 16%, we saw a very small quantity change, just 3.4% for a very small elasticity coefficient. Okay, now let's think about supply elasticity. I'll stay in the agricultural market. Let's think about potatoes, and it's dollars per pound, pounds per week. And I'll start us off at a price of 25 cents per pound and a quantity purchased at that price of 5 million pounds. And price goes up to 30 cents. Now suppliers, of course, will supply more at higher prices because they can cover higher cost of production. And let's surmise that the quantity goes up to 10 million pounds per week. Okay, we can maybe sketch in our supply curve here, but remember it's the same formula, so we just need delta Q over average Q. The delta Q is 5 million, the average Q is 7.5. Delta P here is 5 cents, and the average Q, the midpoint between 25 and 30, would be 27.5, or 0.275. Okay, so we work all of this out. We get 0.67 on top, divided by 0.18 on the bottom, and that's going to be approximately 3.6. So that's much larger than 1, so we can label this as elastic supply. Okay, let's do one more supply elasticity. Now I'm looking at the supply of 3-bedroom apartments in Springfield. So price now is dollars per month, that's the rent, and quantity is in the units offered per month by landlords and apartment complexes. And we'll say that the price starts at $1,000 a month, and at that price in this town, landlords offer 2,000 units, and the price goes up to say 1,200. And because in the short run the supply of apartments is relatively fixed, it's pretty difficult for them to increase supply. They might be able to maybe get some units that are being cleaned or repaired and kind of hurry that along and get the supply up just a little bit. So let's say it only goes up to 2,050, and then we have a supply curve that looks something like that. Okay, and we're working with our same formula. Hopefully this is getting pretty routine by now. Change in quantity is just 50. The average quantity would be halfway between 2,000 and 2,050. That would be 2,025. Change in price is $200. The average is going to be the midpoint between here, 1,100. And this works out to, you can do this on a calculator, 0.0247 over 0.187. And when we solve that, we get 0.136, which is, well, less than 1, a very low coefficient. So we would label this as inelastic supply. And again, if you think about the constraints on increasing the supply of apartments, it makes sense. It's even if landlords wanted to, in the short run, it's difficult for them to build more buildings. Now, in the long run, we might surmise that the supply curve is much flatter, And the same increase in price here would yield a much bigger increase in quantity. So we could think about long run elasticity versus short run. Okay, but for now we're just focusing on calculating that coefficient and getting this formula down. And that's really about it. Now, sometimes you might be asked to find the change in consumer or producer surplus given a change in price and quantity. And let's go back to our oranges example, and I'll quickly show you how to do that. It's pretty straightforward. So we don't know what the overall consumer surplus is because we really don't know the shape of this demand curve above this point. Okay, so the existing consumer surplus before the price change was all this in here. And again, we have no way of calculating that without knowing this demand curve. But we do know the change in consumer surplus when the price goes down from $1 to 85 cents, because what we're doing is adding this area right here of consumer surplus. And that area consists of a rectangle right here. And if we just take the area of that rectangle, which is length times width, and then this triangle, this extra triangle of consumer surplus here, which the area of course is 1/2 base times height. And we can calculate those because we know the magnitude of them, and then we can add those up and find the change in consumer surplus. So the area of the extra rectangle worth of consumer surplus is 15 cents times the 10,000 units here. And then the area of our extra triangle of consumer surplus is 1/2 times a base, which is the extra 6,000 units, times the height of 15 cents. Okay, so we'll work all that on the calculator. First the rectangle, 15 cents times 10,000. We get extra 1,500 of consumer surplus, and that's dollars, $1,500 worth of value for the consumers. And for the triangle, we're going to get 0.5 or 1/2 times the 6,000 times the 15 cent height. That's 450. So when I sum these up, I get a grand total of an increase of 1,950. Okay, so it's pretty straightforward to find the change in consumer surplus. Likewise, we'll do the same thing with producer surplus. We can quickly do that in my potatoes problem. And the change in consumer surplus, again, we don't know the pre-existing consumer surplus. That's this area here because we don't know the shape of the supply curve. But we do know that when we went from 25 to 30 cents, we added this area here. And this area consists again of a rectangle and a triangle. The rectangle measuring a height of 5 cents times the 5 million units. And the triangle area is going to be 1/2 times the base of 5 million units times the height of 5 cents. And we'll just work this out on the calculator. Extra $250,000 of consumer surplus there. An extra $125,000 worth here. We add those up. We get a total increase. We'll call it delta producer surplus equals $375,000. So it's quite easy to calculate a change in producer consumer surplus with this method.
And I should briefly note here that if we're given a price and quantity change on the supply curve, we're only able to calculate elasticity of supply and a change in producer surplus. We cannot calculate a demand elasticity or a change in consumer surplus because we know nothing about the shapes of the presumptive demand curves. Presumably in this situation, demand did something like this, D1 to D2. We had a rightward shift of demand, which gave us that increase in the price. Likewise, up in my oranges example, we presumably had a shift in supply, something like this, S1 shifted out to S2, which brought us the reduction in price. We cannot calculate a supply elasticity here or a change in producer surplus because we don't know what the shape of the supply curves was. It could have been like this, or it could have been like this.
Now, just to wrap things up, elasticity of demand captures sensitivity or responsiveness of quantity demanded to changes in price. And it's very useful to think about two demand curves that go through the same point. Because when we look at the same change in price, so here we're going from 40 to 50 in price, and you can see that the inelastic demand curve, the quantity doesn't change much at all. It only changes by 5. So it's a relatively small quantity response to a given change in price. Whereas the elastic demand curve has a significant change. Quantity goes from 80 all the way down to 20. Okay, much more responsive quantity change to a given change in price, and hence that's elastic. One good way to remember what's elastic and inelastic is when we're looking at just the shape of a demand curve. The more inelastic demand curve is steeper, and it looks kind of more like a capital I for inelastic. And a more elastic demand curve is much flatter, and you can kind of see that that looks more like an E for elastic. So there's a kind of handy way to remember what's inelastic versus elastic. Hope you found this video useful. Please check back on my YouTube channel for more tutorials and reviews trying to help you understand economics.